This video starts with the last example in Newton's laws and connected particles. A ball of mass 0.1 kilograms falls vertically and hits soft, muddy ground whose resistance is 1.48 newtons. Show on a diagram the forces on the ball, and if the ball's speed was 10 meters per second, find the depth to which it will penetrate the ground. Right, so we're told it goes under the ground. So here we have this ball falling towards this muddy ground. What's bringing it down? This mg, which is its weight, and in the opposite direction we have a resistance force, and it's always from the middle in here, but I'm just going to do them from the edge here, but we should probably do it from the middle. So we have the resistance force of the ground in this direction, and in the diagram here you can kind of see that this is the ground that they've given here, and the ball's gone quite a bit into it, so it could even just half penetrate it. The ball could go down that much, we don't know. So the diagram, my muddy ground, my ball has gone down into the ground, and we need to find out how much it's gone into the ground. So what have we got here? We have mg, m is 0.1, so w, the force going down, is equal to w is equal to mg, so 0.1 g. So w is equal to 0.1 by 9.8, which is equal to 0.98 newtons. That's what's bringing it down. The resistance force is equal to 1.48 newtons. So the resultant force is one minus the other. So this big F is equal to either 1.48 minus 0.98 or 0.98 minus 1.48. So let's have a look here. What's happening to this ball? It's eventually going to stop. So it's slowing down. So we have deceleration, which should be a negative A. So let's have a look at which one gives us a negative A. So this is the resultant force is going to be 0.5 newtons. Force is equal to ma. So I would have my 0.5 newtons is equal to my 0.1 mass times acceleration. So in this case, A is equal to 5 ms to the minus 2. And then in the second one, I'll come down here, we're going to have minus 0.5 newtons is equal to 0.1 A. So A is going to be minus 5 ms to the minus 2. So now if the ball's speed was 10, let's look at this part. Find the depth to which it will penetrate the ground. We have A, and we have the ball speed is 10. We're looking for S, and we know that it comes to rest. So we can use V squared is equal to U squared plus 2AS. So we're going to have 10 squared plus twice minus 5. So you can see here, if it wasn't a minus in here, we would end up having a minus S if we brought it to the left. So we're going to have 10S is equal to 100. 10S equals 100. So S is equal to 10. And we're dealing in meters here. So penetrate the ground 10 meters, which is probably a little bit unrealistic. And now, on to the questions in this section. So question 1. A car has a mass 1,000 kilograms. Its engine produces a tractive effort, a pulling force here, driving force, 2,500 newtons. Resistance of magnitude 500 newtons. The car starts from rest. So once you see starts from rest, jot down U is equal to 0. Find the acceleration of the car. So we want A, and how far we're looking for S. So acceleration and distance. So if we do a quick diagram to find the resultant force, we have my car, I have an effort, driving force 2,500, and I have a resistance, no friction here, of 500. So the resultant force is 2,000 newtons is my resultant force. And we know that force is equal to ma. So this F is equal to ma, my 2000. I need either mass or acceleration. When you can see here, we're looking for acceleration, so we got the mass here is 1000. So 1000A. So A in this case is 2 ms to the minus 2. And we're looking for how far it will travel. So we have A, S, we're looking for it. It started from rest. So the one variable they give us in the first 20 seconds. So t is equal to 20. So S is equal to ut plus a half at squared. So the distance traveled, this gives me 0. So I have a half by 2 by 20 squared. Well, the half and the 2 cancel, and 20 squared is 400, and we're dealing in meters. Question 2. The boat has mass 120 kilos. A man pulls the boat in shallow water by means of a horizontal rope. So here it is here. So we might fit question 2 in here. So I have my boat, my horizontal rope, and the resistance is 40 newtons. So I have 40 going that way, and he is pulling it. The tension in the rope is 100 newtons. So that's this way. My tension is 100 newtons. So my resultant force here is going to be 60. You can just write therefore 60 newtons is equal to F from your diagram. So 60 newtons is equal to ma. 60, I'll just leave the newtons out for now, is equal to the mass, 120 kilos. 120A, so you can see A has to be a half. A is equal to 0.5. And ms to the minus 2 for acceleration. So what else do we need here? We have we're asked find acceleration. If the man's wife, who has mass 60 kilos, gets into the boat, what will the acceleration become, assuming all forces remain the same? All that changes here, the 60 is the same. The mass of the boat has gone from 120 to 180. So you can see acceleration becomes a third, 60 over 180. ms to the minus 2, or 0.33 recurring. ms to the minus 2, so you can see it's slowed down. Question 3. A bicycle has mass 60 kilos. And its rider has mass 90 kilos. It's a pretty heavy bicycle. And there is air resistance to motion of 40 newtons. Find the driving force needed to accelerate the bicycle and rider with an acceleration of a half. So quick diagram. We have this mass here. It's 100 and it's 60 and 90. It's 150 kilos. And it has to be pulled in this direction with an acceleration of a half, and we're told resistance to motion is the 40. So we have tension going that way. So my resultant force is T minus 40. So that F has to be equal to my ma, which is 150 times a half. So T minus 40 is 75. So the driving force here, which is what we're asked, the driving force needed, or the tension, is 115 newtons. If the rider's mass was doubled, find the driving force needed for the same acceleration, assuming the resistance made the same. So all that's changing here is we have his weight changing. So his weight is doubling. So he's now 120. No, he's now 180. And 60 is 240 going on in here. Big T. We have the same forces. Could be going uphill, or it could be wind, The road surface, friction, we'll deal with all those later. So here we're going to have t minus 40 is equal to 240 by a half. So t minus 40 is 120. So this time t is 160 newtons. Question 4. A go-kart and its occupant have total mass of 120 kilos. Let's do it down here. Here's my go-kart. It's 120 kilos. The girl pulls the cart and its occupants by means of a tight horizontal rope against a horizontal resistance R. So my T and my R. So we always go in the direction, we always start in the direction up here. If I just go, I'll change the color actually, and I'll go, if we had this, whatever it was, moving in this direction, we start with our T minus our 40. Same here, it was going in this direction, we had our T minus our 40. So here again, we have T minus R. And what are we told? The tension in the rope is 40 newtons. So this is my 40. So I have 40, because it's going in this direction, minus R is equal to M times A, which is 1/8. So 40 minus R is equal to 1/8 of 120, which is 15. So R would have to be 25 newtons. Question 4. Question 5. A bullet of mass 60 grams, and then we have meters per second, and we have newtons. I'm just flicking through. So we're going to change that grams to, let's change that grams to kilograms. 60 grams is equal to 0. Well, that'll be 100 grams, wouldn't it? 0.1 kilo. So it has to be 0.6 kilograms. So we have its mass. We also have its speed. U is equal to 150 meters per second. It's going to stop at some point, so the final velocity is 0. And we're told resistance here is 900. So resistance is equal to 900. Now because it's slowing down, this will be a minus 900, and you'll see why here just in a second. So if we have my force is 900 is equal to MA, 0.06 times A, we'll get acceleration, and 900 divided by 0.06 is 15,000 will be my acceleration, but that would mean it would be getting quicker. So we can see here how this resistance force is a minus, and acceleration is a minus 15,000. We're also asked, well, we're told, or we're asked how far into the wood will the bullet penetrate, right? How far? So we're looking for distance. We know the final velocity is 0, and we know its speed is equal to 150. So we can use v squared is equal to u squared plus 2as to get the distance here. 0 is equal to 150 squared plus twice minus 15,000 by s. So 150 squared divided by 30,000 is equal to s. So it's going to penetrate the wood. 0.75. 22,500 over 30,000. So that's 0.75 meters or 75 centimeters. Then we'll go on. I think there's one more question here. Question 6. Stick it over there. A cyclist covers 8 meters from rest in 8 seconds. S is equal to 8. U is equal to 0. And T is equal to 8. The mass of the bicycle combined with the cyclist is 80. Mass is equal to 80. And resistance is 20 newtons. Find the constant driving force. So we can definitely get A here using S is equal to UT plus a half AT squared. 8 is equal to 0. And I've got a half by A by T squared, or 8 squared equals 64. So 32A equals 8. So A is equal to 1 over 4. That's ms to the minus 2. And now we'll bring in the resistance force of 20. There's a resistance of 20. Find the driving force. So here we are. We have a cyclist. It's going in this direction. The resistance in this direction is 20. So my force, my tension this way, T minus 20, because the cyclist is going in this direction, is equal to MA, 80 by a quarter. So T minus 20 is equal to 20. So T in this case, the driving force, is 40 newtons.